It's me, Paper Pilot here, back with another video. Today we are going to be solving Physics Paper 1 to February March 2026 variants, as your exam is on the 3rd, I think 3rd or 2nd of June. So here we go. So the first question we have here is, what is the value of the ratio 1 km by 1 nm, which is nanometer? So 1 kilometer, to convert it into same units, so 1 kilometer is 10 to the power 3 meters, while 1 nanometer is 10 to the power minus 9 meters. Okay, so if you cancel them out, right, I'll just use the calculator. We get 1 into 10 to the power 12, hence the answer is D. Right, now next question. Sorry, excuse me. What could reduce systematic errors? Now, systematic errors is because of the flaw of an instrument, right? So it's not like random error. So first option A is averaging a large number of measurements. This is not a random error. This is the instrument's fault, not the user's. So it will not be A. Careful calibration of measuring instruments. Yep, that's correct. Reducing the sample size. Nope. Repeating the measurements. Nope. Answer is B. Very simple. Now, a student measures the current and the potential difference for a resistor in a circuit. So current is given 50. Okay. Okay. So the measurements are used to calculate the resistance of the resistor. So the formula for resistance is V by I. What is the percentage uncertainty in the calculated resistance? First, let's find the calculated resistance. It's milliamps. It's millivolts. So milliamps to amps. So it's going to be so you could just find a percentage uncertainty total. So let's just find first uncertainty in I. Right. So 0.001 by total. Both of them are in milliamps, so we don't have to convert it. Okay. So, but wait a second. V by I. Right, so this into 100, which we get as 0.02. And now the uncertainty in V, right? So 0.1 by 500 into 100, which is also 0.02. So if we add them up, we get 0.04. Hence, D is the answer. Now, graphs can be used to represent the motion of an object. Which relationship between a quantity of motion and a property of a graph is correct? So acceleration is the area under the velocity time graph. Nope, it's the gradient. Acceleration is the gradient of velocity time graph. Yes, this is correct. Displacement is the nope. Velocity is the area. No. The answer is B. This is very straightforward. Now, the water surface in a deep well is 78 meters below the top of the well. A person at the top of the well drops a heavy stone down the well. Air resistance is negligible. Okay. The speed of the sound is 313. What is the time interval between the person dropping the stone and hearing it hitting the water? Okay. So this is the well. He drops it. Well is 78 meters. That's the distance. And top of the wall, he drops heavy stone down the wall. The speed of the sound is given. So let's use the formula S equals to ut plus half a t square. Right. So the distance given is 78. Initially, it is 0. The initial speed is 0. And acceleration is same as gravitational constant, 9.1 into t square. So for t, if we calculate it, get 78 into 2 by 9.81, which we get as 3.988 seconds. Now we know the time enough to find the distance. So this is the time for it for the stone to fall down, right? And we're also hearing it back up. So let's call the second time where he hears it t2. So the distance is this, and the speed is 330. So we get 0.236. So now if we add these two times, 3.988 plus 0.236, we get 4.22. The reason we're adding is first, like the stone falls down 78 meters, then the sound is like when it drops, there's a sound, right? And it reflects up, and then you hear the sound. So we have to add the time. So the time it takes for it to fall down, and the time for us for hearing it hit the water. That's why we're adding it up, and we get 4.22 seconds. Now, a toy car moves in a straight line. The graph shows the variation with time of the displacement of the car from its initial position. Okay, so displacement time graph is given. So from this to this, so let's call this like t plus 1 plus half seconds to t2 plus half seconds. So initially from rest, this means constant speed. So over here constant speed, and over here it's at rest, and then constant speed again, negative direction. So a student investigates whether the forces acting on the car are in equilibrium at 4 times, t1, t2, t3, and t4. At which times are the forces acting on the car in equilibrium? So at rest, it's technically at equilibrium, and from here to it's also at constant speed. So that's still in equilibrium, since here acceleration is 0, here acceleration is also 0, and here acceleration is also 0. So basically in all of the times it's in equilibrium, right? So the answer here, but not t1, because t1 it hasn't even started here. t2, it is at equilibrium. t3, it's also at equilibrium. t4, it's also at equilibrium. So the only options that matches this is B. Right. Now, next question. Now, this is actually a past paper question. I don't remember which year, but this is definitely a past paper question. So they just repeated the whole thing. So a car travels anti-clockwise along a horizontal circular road of radius 12 meters as shown. The car takes 4 seconds to move from position P to Q. Okay. What is the magnitude of the average velocity of the car journey from P to Q? Now, average velocity is total displacement by total time. Now, from P to Q, what's the displacement? So this is a right angle triangle, right? So if we consider this, let's say this straight line, so it's a right angle triangle. This is 12 and this is a radius, so hence this is 12 as well. So we can just use Pythagoras theorem. 12 square plus 12 square, which we get 16.97 meters. Now, using the formula again, this one, time it takes from P to Q is 4 seconds, and the distance is 16.97. 16.97 by 4 is 4.24, which is the correct answer. That means answer is A. Right. Now, question number 8. A person is suspended from a rope vertically below a helicopter. The helicopter and the person are stationary above the ground. Stationary. That means it is at equilibrium. So, which force forms a Newton's third law pair with the force of the person? So, what is Newton's third law? So, Newton's third law. Newton's third law says that two forces will be equal but opposite in direction. And also, they have to act on different objects. So, which are the Newton's third law? So, the first option A is the force of tension in the rope. So, basically, this, and wait, force pair with the weight. So, weight is acting downwards, right? The person's weight is acting downwards, and the tension is acting upwards. But the tension will not be the same, right? The tension will not be the same as the weight, so it's not correct. The force of upthrust on a person. Upthrust, no. Upthrust, it's not going to be upthrust. The gravitational force applied by the person on the earth and the weight. Yeah, that's correct because it's on different objects, right? It cannot be upthrust because it's the same object. So tension different. It cannot be this because it's acting on the same person. Yeah, if weight is also acting on the same person over here, it has to be on different objects. Different. Now, the gravitational force applied by the person on the earth, it's on the earth. And it's the opposite of weight. Yeah, it's gonna be C. Gravitational force applied by the person on the helicopter. No. That won't be equal. The weight of the person is the gravitational pull of the earth acting on the person. Hence, the third law is on the gravitational pull of the person acting on the earth. Hence, the answer is C. The rest don't really make sense. Now, two small moving particles collide. It's a momentum question. After the collision, the particles move in different directions. What is essential for a total momentum to be conserved in the collision? So, what is the law of total conservation of momentum? It is total momentum before collision is equals to total momentum after collision in isolated system. Right, that means no external forces will be there. So hence the answer is A. No external forces. Nothing else really matters. Now, number 10. This is, I think, also similar to our past paper questions, though they did change it a bit. So block 1 of mass 3 kgs, this is 3 kgs, is moving on a horizontal frictional stable. A rope with negligible mass is attached to the block. The rope passes over a frictionless pulley. Block 2 of mass 1 kg is suspended from the other end of the rope as shown. The blocks accelerate. The acceleration of free fall is g. The unit of g is given. The tension of the rope has the unit newtons. So what is the tension in the rope in terms of g? So this rope is having a tension. So let's call this tension T. And we can use Newton's second law, which is resultant force equals to the rate of change of momentum. So mass into acceleration. So if we consider the force here is T, that's mass into acceleration, and the mass is for block 1, it's 3 into A, so acceleration is T by 3. This is for block 1. For block 1. What about for block 2? We're out of space, but wait. For block 2. For block 2, tension is the same, T, but over here there's another force acting, which is its weight. Right, the weight. So the resultant force is the weight, which is 1 into 9.81 minus T equals to the mass into acceleration. So the acceleration will be 9.81 minus T. So we have two equations here, right? So let's just simultaneously solve this, and if we simultaneously solve this, we get that the tension will be 3g by 4. Right, that's your answer to number C. Now, the mass of an object can be determined by its relationship to other physical quantities. 3 relationships are shown. Number 1, resultant force on object by acceleration of object, mass of an object, which basically means that this is actually the same as what we used before, F equals to ma. So if we take m, it's force by acceleration, the resultant force on it. Okay, so this is correct. The linear momentum of an object by velocity. So momentum equals to mass into velocity. We take mass subject momentum by velocity. So linear momentum of an object, yeah, this is also correct. Now weight of an object by the acceleration of the object. That is not true. This is true only when the mass of an object is E is in free fall. Right. Not always the case. So 1 or 2 is always the cases. Hence the answer should be A. Should be B. Yeah. Now, number 12. A basket is sliding in horizontal frictional surface with a velocity of 30 centimeter per second. The mass of the basket is 2. Okay. This seems to be a momentum question. Okay. So the block of mass 2m falls vertically into the basket. The block and the basket move together with the same horizontal velocity v. Okay. So so there is horizontal. This is horizontal momentum. But this, when it collide, this one is vertical momentum. So initially the horizontal momentum, is the mass m into 30, but it then gets added to the mass of the block. So the final horizontal momentum is m plus this, so 3m into v. Right. So if you use the conservation of momentum, initial momentum is the final momentum, so m into 30 is equals to 3m into v. If you cancel this out, we get v as 10. Hence velocity v is 10. Right? Now, question number 13. The two children are balanced horizontal in equilibrium. This is a moments question. So this is one mass. This is one. The mass of child Y is 15 kgs. The mass of child X is 20 kgs. The pivot is here. Okay, and the mass of the plank is 7 kgs. This is given. Okay, so this is also a past paper question. I'm pretty sure. So the plank is uniform with a mass of 7 kgs and length is 11. Okay, so the pivot is the midpoint. Okay, so this is the midpoint. This is uniform midpoint. Okay. So this is the midpoint. From here to here is 1.5 meters. From here to here is again 1.5 meters. Now, child X has a mass of 20 kgs. Okay, we already read this. Distance X from the pivot. Child Y has a mass of 15 kgs and distance Y from the pivot. What is the value of the ratio X by Y? X by Y. So let's use the law of moments, which is at equilibrium, the total clockwise moment is equals to total anti-clockwise moment. So what is total clockwise moment? Total clockwise moment is from child Y, since it's going this way, and the child X is going to be the anti-clockwise moment. So total clockwise moment will be the child, which is 15. We don't have to convert it to weight because all of it's mass, so they will just cancel out. So let's just think of this as mass into Y. The distance is Y from the pivot, right? This is from X from the pivot. So this from Y, and total anti-clockwise moment is the mass of X, the child X, into this. Okay, so we have the first equation, 15y equals to 20x. Right, so x by y should be 15 by 20. So x by y is 0.75. Very straightforward. Now, next question. Oh, this is definitely a past paper question. So the diagram shows two ways of hanging the same picture. Diagram Y, diagram 1, diagram 2. This is a nail, R1, R2. Okay. In both cases, a string is attached to the same points on the picture and looped symmetrically over a nail in the wall. Okay, so this is a nail in the wall, this is a nail in the wall. Okay, so the forces shown are those that act in the nail. The weight of the string is negligible. Okay, so we don't have to care about the weight of the string. So in diagram 1, the string loop is shorter than in diagram 2. Okay, yeah, it is shorter. This is longer. Diagram 2 is longer. So which information about the magnitude of forces is correct? So one thing we need to take into consideration is that both R1 and R2, are they different or same in magnitude? They will be same. The reason why R1 is equals to R2 is because on both the diagrams, all right, this whole system, I guess you could say, is holding up the exact same picture, right? These are the exact same picture at rest. So the pictures are at rest and holding them up. That's why it's in equilibrium. So the total vertical force provided by the nail must perfectly balance the weight, right? So this tension, that means T1 and T1, this tension, this whole thing should balance the weight, or else it won't be at equilibrium. The picture will like fall down or something. Since it is perfectly at rest, that means this R1 must be equal to the weight. The same for R2. Hence, if they're equal like this, hence R1 must be equals to R2. So basically R1 equals to R2, which is equals to the weight. Now for tension T. So there's an angle formed between here, right? Let's call this theta, and let's call this theta 1 and theta 2. So just by looking at a diagram, you can clearly see that theta 1 is greater than theta 2. Right. So if we resolve the tension here into vertical vectors, right? So what is going to be this? This will be cos t1 cos theta. And whenever you put a value in, whenever you increase the theta, for example, let's say we put t1 cos 45, right? So for 45, we get 0.7 degrees. If we increase the theta for like cos 90, we get 0. Then cos 140, we get negative. So as theta increases, cos theta decreases, right? And as cos theta decreases, your t1 will decrease as well. Hence your r1, your t1 will decrease. So if t1 decreases as theta increases, that means your t1 will be greater than t2, because at t2 the angle theta 2 is less. So if theta 2 is less, your cos theta will be more. Using this, right? Hence your t1 should be greater than t2. So the only thing that matches this is this, B, right? Now, question number 15, the diagram shows 4 metal cylinders submerged inside a container of water. Which cylinder has the greatest pressure on its top surface? So pressure is force area, but since it's in water, right? So the pressure is also rho hg, which is h here is the depth, this is the density, this is gravitational potential energy. Okay. So which cylinder has the greatest pressure on its top surface? So all cylinders are in the same liquid water, so the density won't really matter, so this is not gonna work. But what about the depth? The depth here is at different points. So if you look at cylinder C, the top surface sits at the lowest point. This is the lowest point, right? While it's the deepest down, meaning that it will experience the most pressure because it's deepest down in water. Hence C is the correct answer, hence it's the most deepest down. Area won't play a factor here, so don't consider the fact that A and C are more thicker than B and D, hence it's going to be 1 or AC. No. And if it's submerged in water, the only formula that applies is rho hg. Rho and g is the same for all, and the height is different depth, and this is the most lowest down, the bottom. It's basically at the bottom. Hence C will experience the greatest pressure. Now, question number 16. 3 solid objects cube P, cuboid Q, and cylinder R are shown. Okay. The dimensions and masses of the objects are given in terms of x and m. Okay, x by pi, m. Okay. Which objects have the same density? So the formula for density is mass by volume. So let's find the density for all 3 of these. So for QP, the volume is x cubed. So the density for P is m, the mass is m by x cubed, while for Q the volume is 2x into x into x, which means 2x cubed. So the density for Q is 4m by 2x cubed. This and this cancels out, so 2m by x cubed. What about R? To be honest, we don't even have to calculate R because P and Q are already different, right? So it cannot be P and Q already. We can cancel this R, and P and Q R we can also cancel this. P and R, I mean, you know what? Let's still calculate this, right? So R is X is the radius. This is the mass, and this is the depth height. So we can consider this as a cylinder. What is a volume cylinder? Cylinder volume is pi r squared to h, which is x by pi. So this and this cancels out, which leaves just x cubed. And mass is this. Hence, your density for r is mass over x cubed, which is the same as this, equal. Hence, your P and R are similar. Hence, the answer is C. Now, 17. A small ball is projected into the air from horizontal ground. The diagram shows part of the ball, the path of the ball. The path of the ball. Okay, so it's initial at x, and then no, it's initial at y, and it moves up towards x. Okay, so it's 8.8 above the ground meters. So the ball leaves the ground at point x with a kinetic energy of 8. So over here it's 8.0 joules. Short time later the ball is at point y where there's a kinetic energy of 3.5 joules. So over here it's 3.5 joules. So point y is at a vertical height of 8.8 meters above the ground. Air resistance is negligible. Okay, so first we define the gravitational potential energy, which is the GPE. So what is the gain in GPE here? So it's basically initial minus final of kinetic energy. So 8 minus 3.5. It's going to be 4.5. So since this is the GPE equals to M into G into H, mass, we calculate the mass. This is 9.81, and this is the height is given 8.8. So what is mass? We get mass as 0.052 kgs. Hence the answer is B. Excuse me. Now question number 18. A boat requires a power to move through still water with a constant velocity. There's a drag force F acting on the boat. What is the velocity of the boat? So there is a formula which is power is equals to force into velocity. So it's at constant velocity, so V is constant. This is constant. But if we make V the subject, which is P by F. Well, this is very straightforward. Like, okay, this is just A. No, not A, sorry. This is just C. Just rearrange the formula, that's it. Now, when the speed of an object increases from 10 meter per second to 12 meter per second, its kinetic energy increases by E. Okay, so what is the increase in kinetic energy of the object when its speed increases from 70 meters to 18? Okay, so basically if you make two separate equations, so let's say half m v square so this is the change of this is E. Basically means half m 20 square minus 10 square into 300 equals to E. So E is basically 150 m. Right. Now what about the second equation? Half m 80 square minus 70 square. Let's consider this. We don't know what this is exactly. Let's consider this E as well. It won't be E, but like 80 square minus 70 square into half. 750 M. So what is 750 divided by 150? That is 5. Hence it's going to be 5e. C is the answer. Sorry, C is the answer. Now, question number 20. Trains supply coal to a power station. The table shows quantities describing the operation of the power station. Okay, so this is the power station output, number of trains per day, mass of the train, energy from 1 kg of coal, number of seconds in 1 day. Okay, units is not given for all actually. Wait. Okay, so which expression gives the efficiency of the power station? So what is the formula for efficiency? Let me just do this now. Efficiency is useful power output by total power input into 100 if we give it as percentage. Now useful power is going to be P, this is the average output, while the total input energy is going to be the number of trains per day, N, into the mass of coil on a train, into E, which is the energy, total energy that's used. So how can we find E? So total input power is N, number of trains per day, into the mass, into E, which is the total energy needed, divided by the time, which is S. Power equals to energy by time, hence we divided by S. Now, if we use efficiency, total input power is P divided by this thing, NME by S, which we get is PS by NME, which means the answer comes out to be A. Right. Now, next question. 21. Which descriptions of objects undergoing elastic and plastic deformations are correct? So what does A mean? Object undergoing elastic deformation, A is permanently deformed. No, that's not true. It goes back. Object undergoing plastic deformation is not okay. This is also wrong. This one should be permanent. This one should be permanent. Permanently deformed. That means even if you remove the load or the mass or whatever, it will not go back to its original length. But in elastic deformation, it does, because it hasn't reached its elastic limit yet. So this will be not permanently deformed, and this will be is permanently deformed. So the answer is D. Now, a force F, extends a length L of a uniform wire by extension E. The wire has diameter D and obeys Hooke's law. Okay, it obeys Hooke's law. That means, all right, still proportional. Now, what is a Young modulus of the material of the spring? So Young modulus is stress over strain. And what is stress? Stress is force over area. Strain is extension over original length. This comes out to be FL over AX. So which actually corresponds to this? This is the only thing that matches. Nothing else matches. D. Because area is pi r square. If you write it in D terms, it is pi d squared by 4, and this 4 is multiplied here, hence it's 4d here, right? Hence it's D. Okay. Now, question number 23. This seems to be an also a past paper question. Okay, so an 8 Newton weight is attached to the lower end of a spring, which is fixed at its upper end. The weight is initially held rest at position X. Okay, so over here it doesn't move yet. At and the spring is unstretched. So this is the original length of the spring. So the weight is then released. Okay, so it's released, and it falls to position Y from position X position. So this part is the extension, and then at 4 centimeter below X, the weight oscillates and then eventually comes to rest at position O, which is 2 centimeter below X. Okay, so that means it is somewhat plastically deformed, or else it will go back to this, but it's not. Okay, so how much energy is lost from the system? Okay, so from here to here, it's extended. So elastic potential energy is half Fx. Force 8 newtons. The extension is 4 centimeter. Which comes out to be 16. But we have to divide this by 100 because 8 is in centimeters. 0.16 joules. So from here to here, it's 0.16 joules gain. Now from this to this, it goes back up. So there's gonna be gain in GP. Mass, let's say 8 by 9.81. 9.81 into what is the increase? 2 centimeters. Divide, got. Alright, so the next part is this comes out to be the same. Wait, that's not what it should be. 100 into 2. This comes out to be 0.16 as well. So the answer is D. Alright, so since 0.6 plus 0.6, 0.32. Now, what is an electromagnetic wave? Wait. Guys, my internet is going pretty slow. Wait, it's not loading, is it? Wait, let's fix this real quick. Alright, so an electromagnetic wave has a frequency of 3.3 into 10 to the power 14 hertz. Which principal region of the electromagnetic spectrum is this wave in? So we know the frequency. Okay, let's first find the wavelength. So V equals to F lambda. If we get this, V by F. This is vacuum, so 3 into 10 to the power 8, which is the speed of light. 3.3 into 10 to the power 14. So what does the wavelength? We have to memorize actually like the ranges of the wavelength, so it's better to memorize it. It's basically the only way you can solve these type of questions. We get 9.09 into 10 to the power minus 7, which falls in UV. It's either UV or visible light, one or between. So the answer is infrared. It's not visible. Visible light is more, and UV is also more, right? So the range is something like this. First is your radio waves, then microwaves, then infra, then visible, then UV, then X-ray, and then gamma. So as you go down this list, your frequency will increase. But your wavelength will decrease. Hence, gamma is it has the largest frequency, but also the smallest wavelength. So now, 25. A wave is on a stretched spring. Causes particles to vibrate. Um, at one instant. So PQR are particles on a string. So which statement about the two particles and the wave is correct? Okay. Number one, if it is a progressive wave, particles P and Q vibrate with a phase difference of 90. P and Q. This phase difference is not 90. This is wrong. This is not one quarter of a phase difference, total phase difference. So if it is a stationary wave, particles P and Q vibrate with a phase difference of 90. Stationary wave. Still not true. If it is a progressive wave, particles Q and R with a phase difference of 180. This to this. If it is a stationary wave, particles Q and R vibrate with a phase difference of 180. Actually, guys, my bad. This is not infra. It's actually visible light. A mistake there. So now back to question number 25. Okay, so what is this going to be? The correct answer will not be C either, because if it's a progressive wave, particles Q vibrate at phase difference 180. If it was 180, then R wouldn't. Then Q and R would not be here. Q would be here, and let's say from here to here is one complete wavelength, right? So R should have been somewhere around here, right? So the only answer is D. If it is a stationary wave, particles Q and R vibrate with a phase difference of 180. Yeah, that is true. In stationary waves, like all the particles within a loop. So this is like a loop, right? From here to here, this is like a loop. All loop vibrate in phase, right? But particles in an adjacent loop, which are like separated by a node, vibrate completely out of phase, like for example 180 degrees. So hence Q and R belong to like opposite loops. This is from this loop and this from this loop. Hence they are going to be 180 degrees out of phase. This is only applicable if it's stationary waves. Hence D is the correct answer. Now, what describes the displacement of a wave of a particle on a wave? Distance in a specified direction from its equilibrium position. Yeah, this is correct. This is correct. All right. So, oh, this is completely from a past paper question. So, a beam is vertically polarized light of I naught is incident normally on a polarizing filter. The transmission axis of a filter is at angle 60 degree to the vertical. Okay. Now, the transmitted light beam is then incident normally on the second polarization filter. The okay, it's perpendicular to the vertical as shown. Okay, so it says the intensity of the light beam that emerges from the second filter is IT. So what is the ratio IT by I naught? So we have to use Malice's law here. So let's call this I1. So I1 is I naught cos squared theta. So over here, cos squared theta is the difference between the direction of the polarized light and the transmission axis of the filter, which is 60 degree. So I naught 60, wait, cos 60 square, which is I naught into 0.5 square, which is 0.5. So 0.25 I naught. Now what about number 2? So the wave is traveling just like this, and it's this time the transmission axis is 90 degree. But this is not the cos squared theta. The cos squared theta is actually this part. So if this is 90, first is 60, that means this part is 30. The angle between the transmission filter and this is 30. Right. 90 degree minus 60 degree is 30 degree. So let's call this I2. So I2 is basically your I1. No, not I1. I naught cos squared theta. And we already know, no, I1 cos squared theta. We already know what I1 is. I1 is 0.25 I naught. So 0.25 I naught into cos squared 30. Right. So now if we make a ratio of this, so the ratio would be 0.25 I naught into cos square 30 divided by 0.25 I naught. This roughly comes out to be 0.1875, which is, if you round them off, 0.19. Done. Now, a car is driving along a straight road while emitting a sound of constant frequency. There is a stationary observer at each location X, Y, and Z. So there's one person here, right? There is another person here. So from X to Y, the car accelerates uniformly, constant acceleration from rest up to a high speed. Okay. And from Y to Z, the car continues at this constant high speed. Which observer will hear the highest frequency of sound, and what is the position of the car when this frequency is heard by the observer? So you can just use the formula. Observed is this V by sound is V by. Okay, so since it's moving towards, it's going to be minus here. If it was away, then it would be plus. So the correct answer. So if you use the concept of Doppler effect, which is the change in relative frequency is equal to change in speed. So the higher the speed of the car, right? If it moves towards, the higher the frequency. So the higher the speed is at Z. So the car moves away from X, right? And moves past Y, but it drives directly towards Z. So between x and y, the car travels at a maximum constant high speed directly towards z. Therefore, the observer at z experiences the highest change in speed, which means the highest frequency heard. So it's going to be at z, not at x, not at y. At x is moving away, at y, because of the high speed, it's going to pass really fast. So this guy will be clueless, like what the hell just happened. While at z, this guy will hear the sound. So it's going to be either going to be D. And the position of a car would be between y and z when he hears the highest frequency. Right. Now, moving on, question number 29. Each diagram shows a stationary wave on a stretched spring. Which diagram is correctly labeled? Okay. So, what is node? Node is when the displacement or amplitude is 0. Minimum displacement 0. While antinode is where it is maximum from equilibrium position or amplitude. So over here, node is here and antinode is here. This is completely wrong. From here, antinode is here, node is here. This seems right. But we have to also consider the wavelength. This is not the wavelength. This is also not the wavelength. From here to here is a wavelength, which is correct. This is a node, this is antinode, also wrong. From here to here is a wavelength. This is an antinode, this is a node. Yep, D is the correct answer. Now, question number 30. Two coherent electromagnetic waves. Coherent means constant phase difference between the two waves are traveling in a vacuum. The two waves meet at a point. So basically they superimpose, I guess. At this point, the two waves have different intensities. Okay, so which statement about the wave is not correct? If they have different intensities, that means they have different amplitudes. And if they have different amplitudes, it cannot be destructive interference. Because destructive interference means that the amplitude will be same. Okay, so which statement is about the waves is not correct? They have a constant phase difference between at that point, that is correct. They have the same amplitude at that point. They have the same frequency. They meet. So what is not correct? They have the same amplitude at that point. They do not have the same amplitude because they have different intensities. If they have different intensities, that means they have different amplitudes. Because intensity equals to A squared. Right. Hence, it is going to be B. Now, 31. The laser light of a single frequency is incident normally on a diffraction grating with 5 into 10 to the power lines. A diffraction pattern is formed on a flat screen which is parallel to the grating. The screen is at a distance of 35.5 centimeters from the grating. Distance between the two first order intensity maximum is 15. What is the wavelength? So for this, we have to use the formula d sine theta equals to n lambda. So, and also another formula is d equals to 1 by n. So let's first find d. So 1 by 5 into 10 to the power 5. Okay, so it's 2 into 10 to the power minus 6. So now we know d. So what is lambda? Lambda equals to 2 into 10 to the power minus 6 into sine theta. So it's incident normally, so we can just write this 90 degrees divided by n. So it says between two first order intensity maxima. So divide that by 2. Let's see what happens. The answer comes out to be 1 into 10 to the power minus 6. Which is around... Okay, but this is not part of the options. Maybe I messed something up. Hold up. Okay, so this question is actually a bit more tricky than it seems. So first part that we figured out was 1 by n, and we figured out that d is 2 into 10 to the power minus 6 meters. Right. But none of the answers are matching, so I tried drawing a diagram here. So it says that diffraction patterns formed on a flat screen which is parallel to the grating, and the screen is at a distance 35, so d is 33.5. And the distance between the first two order of density maximum is 15. But I had to make a right angle triangle, so if this is the center maxima, and between two first order, so from this to this will be actually half, because distance from the center maxima to one first order maxima is half the total distance between the two first order maxima. So x here will be 15 by 2 and 7.5 centimeters, which if you convert to meters is 0.075. 0.075. So this is 0.05 and this is 3.5. So we have to find the angle theta of this part. So if we use the formula tan theta, we get 0.075 divided by, convert this to meters, is 0.335. So roughly comes out to be, theta comes out be 12.6 degrees. Now we've used the formula, and the value for the wavelength is be 2 into 10 to the power minus 6 into m, no not m, into 0.2185 which comes out to be 4.37 into 10 to the power minus 7, which is, in terms of nanometers, is 437 nanometers. Okay, so this question was pretty tricky. Like, this one needs a bit of more thinking, but it's possible if you draw a diagram, that is. Now, question number 32: which graph represents the variation with current, and V for a filament lamp? Now, for a filament lamp, both the current and the voltage will increase. Right. Now for IV graph, wait, just draw this real nice. So consider that there is current voltage graph. The filament, the graph shape will roughly be like this. Right. But since this is a VI graph, if you just like rotate this, for example, let's rotating this. If we like, how do I rotate this? Hold up. Wait. Well, anyways, it's not rotating. So if you like, oh, I deleted a mistake. If you rotate this, it will come out to be the shape as this. Hence, the answer is B. Okay. Now, question number 33. What is the definition of potential difference across the period? Potential difference is the energy transferred per unit charge from electrical to non-electrical forms of energy. So in layman's terms, it is not this, it's not this either. The answer is A. Okay. Now, a conducting putty is a substance that conducts electricity and can be molded into various shapes. So a cuboid is made from this putty has length L with X. The resistance between the square faces of the cuboid is 15 ohms. Okay, square faces. So from here to here, it's 15 ohms. Okay, so some more of the putty is molded into a cylinder that has length L by 2. The resistance between the circular faces of the cylinder is also 15 ohms. Okay, so what is the radius of the cylinder? So if we draw a cylinder here, so this is a cylinder, and the length is L by 2. And the resistance between the circular faces of the cylinder, I mean this part is 15 ohms, which means that this from here to here, the length is the same as this. Okay, so this is L. Okay, wait, no, then how is that L by 2? Okay. Alright. So the resistance between the circular faces of the cylinder is also 15 ohms. So what is the radius of the cylinder? So how can we do this? So first, if we can use the okay. So it's made from putty, the same putty. That means the resistivity should be the same. So for the formula for resistivity is R equals to RA by L, and if you make R the subject, it's rho L by A. So let's first find the resistance of the cube. Cube should be rho L by x squared. That means rho L by x squared is 15 ohms, while rho L by 2 by the area, well, by area over here, let's say 2 pi r squared. That's just like r square is 15 ohms. Okay, so how do we do this? Oh, this is not going to be 2 rho L by 2. Okay, so that it cancels out. Pi r square, and this multiplies down, so 2 pi r square. Okay, so if we, both of them are 50, so if we equate them together, x square equals to rho L by 2 pi r square. These two are equal, right? So x square equals to 2 pi r square. So r equals to x divided by root over 2 pi. Hence the answer is B. Okay, not that tricky. So question number 35, each of Kirchhoff's law is linked to the conservation of a physical quantity. Which conserved physical quantities are used in the derivation of Kirchhoff's first law and of Kirchhoff's second law? So the first law is of charge. That means total current entering a closed loop is equal to total current out of that loop. And second law states that total EMF equals to total PD. So the first law is conservation of charge. Second law is conservation of energy. Hence it will be, let's see. Now, question number 36. 8 identical resistors are connected as shown. Ammeter A1 reads 1.5 amps. What is the reading on ammeter 2? So it's correct. So this whole thing, and this whole thing are connected in series. So what is A2? So these are connected in series as well, but this whole thing and this whole thing is in parallel, while this and this is in parallel. Okay. So how do we solve this exactly? So A1 reads 1.5 amps. So from here the current goes from here to here, then it splits, then here to here, then it adds up here again, and then this current goes here to here to here. Okay, this is actually a bit tricky. Alright, so let's take this question from another point of view. So all of these resistors are identical, right? So let the resistance of like an individual resistor be R. So this is R, 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 this is R. Okay, since they're all identical. So the ammeters, okay, so the reading on ammeter A is 1.50 amps. The entire circuit contains of like 2 sections, right? This whole thing is one section, this whole thing is another section. Right, this is one section, this is another section. So let's first see that this bottom section over here, right? This bottom section over here contains one resistor of resistance R in series with an ammeter A1. So the total resistance of this branch should be R. The right branch contains 2 resistors of series. I'm not sure actually. Wait. So let's say the current flows here and here. This is R, this is R, so the total resistance is 2R over here. Resistance is 2R. While from here, this is only R, since it's going flowing from here. Okay. So how can we find a total current? So the ammeter E1 reads 1.5 amps, and since like A1 is on the left branch, right? This is the left branch. That means to the left branch, this branch and this branch are in parallel across. I mean, they're identical, but they're parallel. So what I'm trying to say is that the voltage over here, the voltage coming over here, will be the product of this branch and this branch. What I'm trying to say is basically that this branch and this branch, if we multiply this, it will be equal to this branch and this branch. We multiply this, since this is in parallel and this whole branch is in parallel as well, parallel to one another. So if you cross multiply this, that will be the EMF, that's the voltage that's coming in here. So if you write this in equation, your 1.5 amps will be multiplied into R, this part R, and that will be equal to the current that's on the left hand side, this part, into 2R, hence this, because there's 2 resistance here, so 2R. So if we cancel these R's together, we get 2I equals to 1.5. So I is 0.75 amps. This is the I that's in the right branch. So what is the total current that's flowing? The total current is 1.50 plus 0.75. So this is the total current that's actually flowing in this whole circuit. So let's say this branch over here with ammeter A2. So this part must be 2.25, but let's also look at the left branch over the lower branch. This contains three resistance. This part 3R, so 3R is total, and while over here only 2R. So let's try to do this as well. So let's consider the current flowing here as I3, and let me resolve this way. Actually, now let me just do it over here instead. So I3 into 3R total over here is equals to your I2 into 2R. I2 is a resistance that's flowing here. This is I2, this is I3, and this thing is I1 or whatever IT. So this is equals to this, and if we just cancel this out, we get 3I3 equals to 2I2. Now we already know one of the equations here is I total. So if you substitute this, we get I3 is 2 by 3 I2. That means 2 by 3 I2 plus I2 is equals to 2.25. That means your I2 is 2.25 into 3 by 5. That means I2 is 1.35 amps. I think, okay, this is really hard to explain, but basically your this upper voltage and this are in parallel, hence if you multiply this and this, they will come out the same. So basically first I find out like this amp over here is your 2.25, which is the total of this whole thing. So since we know the total here, we can make two equations, which is I1 plus I2 plus I3. This part is I3, the current coming here, so this should also be equals to I2, which is 2R over here. This upper branch, lower branch, or you can crisscross this as well. So by forming an equation here, we canceled out and we got this equation, and then we put that back over here. That means I2 plus I3 should equal to 2.25. This has to be, so this upper branch can be equal to this. Hence, if we equate this, I2 comes out to 1.35 amps. I'm still pretty sure that none of you guys understood what I just said. I'm gonna be honest, this question gave me a headache, but if you guys want me to make a separate like video or short or something on this question, I'll try to make that. If you guys have any problems, comment down below. I will try to explain it. All right. But as much as I could explain right now, it is 1.35. Okay, let me now erase all this. I need space for this question as well. So, question number 37: a battery of EMF 6 volts at negligible internal resistance is connected to a series with a resistor of resistance 3 ohms and a variable resistance from 0 to 4 ohms. The voltmeter is connected to across the variable resistor. The resistance of the variable resistor is changed. So what is the range of the voltmeter? So answer should be from here 6 for 0 to 4, and it's the voltage here. So we can use the formula for potential divider, which is V out equals to V total. I mean, that's entering this into R out by, not R out, the R that we have to figure out. Let's call this variable resistance. R fixed resistor plus R variable resistor. And when R variant is 0 ohms. If this is 0 ohms, then this whole thing is 0. So V out becomes 0. So it is not this, it's not this. The lowest voltage is from 0. And when the R variant is 4, V out comes to be 6 into 4 divided by 6 plus 4, which comes to be 2. So from 0 to 2, the closest thing is A, since A is the answer. Just use the formula for potential divider and just substitute the values. Very easy. Question number 38. In an alpha particle scattering experiment, a beam of alpha particles is aimed at a thin gold foil. Okay, so the gold leaf experience. So most of the alpha particles go straight through or are deflected by a small angle, yada yada. Which conclusion about the structure of atoms cannot be drawn from this experiment alone? Okay. So most of the atom is empty space. This can be drawn because most of them go straight through. Most of the mass of an atom is concentrated in a nucleus. We also know that because some of them are rebounding, deflected. The nucleus contains both protons and neutrons. We do not know that. We cannot figure out just from this right over here. Everything else we can figure out, but not this. So the answer is C. Now, question number 39. We're almost at the end. In a type of beta decay, an up quark changes flavor to a down quark because a neutron becomes a proton becomes a neutron in a beta decay, which means that this is a beta plus decay. Right. It goes up to down. Proton to neutron. Hence, up to down. This is a beta plus decay. So which row shows the new hadron created in this beta decay and the sign of the charge of the emitted beta particle? It's positive, not negative, and the hadron created is neutron. So the answer is A. Simple, right? Now the last question. Oh, this is actually very simple. Uranium is given as 238 by 92, and it decays into radium 226 by Ra by 88. After a sequence of alpha and beta minus decay, which row gives the correct number of alpha decays and beta minus decay? So let's say it first decays alpha. That means this will minus 4, this will minus 4, minus 2, sorry, minus 2. So this will become 2, 3, 4, become 90. And after that, if we go beta minus, it won't be beta minus because you have to make sure that this becomes 226. And in beta minus only this changes. This doesn't really change. So how else can we do this? So in each alpha decay, your 238. So the only way that the nuclear number changes is through alpha decay. So one thing's for sure, that first is alpha decay, right? So first it's alpha decay, then beta minus. So okay, we subtract this, the nucleon numbers equals 12, and if we divide 12 by 4, we get 3. So there are 3 alpha decays. After 3 alpha decays, it finally becomes this. So after 3 alpha decays, that means 3 into 2, 6. That means 92 minus 6, 86. But over here it's 88, so it increases by 2. So 2 beta minus decays. Since it increases by 1, and since we have to get 2 beta minus decays. So the answer is going to be B. Okay. Nice, and that is the end of the paper. Hope you guys understood everything. This paper was relatively easy, but a few questions could keep you off guard. For example, 36. And what else? And 31. Yeah, these two questions were probably the hardest in the paper. Rest was relatively easy, I would say. Nothing too crazy, and the fact that many past paper questions came, that proves that you guys need to do the past papers. They don't even change the values. Like, for example, this question, it's exact same, like the answer and everything. And there are many questions that are exact same. This question is probably from my past paper as well. This is very common, very common. So I suggest just practice past papers, and I would say to suggest like from 2025 to 2020. Just practice these 5 years, and inshallah, you will ace your paper. I'll pray for you guys, of course. So, yeah, that's about it for this video. If you guys have any questions, any queries, make sure to comment down below. And if you're new to the channel, please make sure to subscribe and turn on your post notifications to get amazing more videos like this. That's it. Paper Pilot out.